FastMCD didn't just appear out of nowhere. It's the result of years of development, refinement, and real-world testing. From its mathematical roots to its implementation in modern data science, this algorithm has come a long way. And just like FastMCD had to go through key milestones to become what it is today, every creator, every innovator, and yes, even this channel needs milestones to measure success. Speaking of milestones, I have one of my own, hitting 100,000 subscribers right here on this channel. And let's be real, I could use a little help with that. If you've been finding this content valuable, if you're learning something new, or if you just want to see more data-driven insights like this, hit that subscribe button and be part of the journey. You'll be helping push this channel toward a huge milestone, just like researchers pushed FastMCD to where it is today. Now back to the algorithm's history. It all started in 1999 when the minimum covariance determinant MCD method was introduced. This was a breakthrough in robust statistics, providing a way to estimate parameters while ignoring the influence of outliers. The problem? It was slow. Computing MCD for large datasets took way too long to be practical. Then came 2006, when researchers optimized the process, leading to the development of FastMCD, a much more efficient version that could handle larger datasets in a fraction of the time. By 2010, FastMCD had been implemented in major statistical software like R, making it widely accessible to researchers and data scientists. Fast forward to 2014, and studies started focusing on performance evaluations, testing FastMCD in different real-world scenarios. These studies proved that it could handle up to 50% contamination and still accurately estimate the true structure of a dataset. That's a serious breakthrough. By 2020, FastMCD was no longer just a standalone statistical tool. It was being integrated into machine learning frameworks, improving data preprocessing for anomaly detection in AI-driven models. And here we are today, using FastMCD in finance, healthcare, engineering, and beyond. It's gone from a purely academic concept to a practical, high-impact tool used across industries. But here's the thing. Development never stops. Just like this channel is growing and evolving, so is FastMCD. What's next for this algorithm? What challenges still need to be solved? That's exactly what we're looking at next. Every great algorithm needs a way to measure success. In the case of FastMCD, it's all about how well it detects outliers, handles noisy data, and scales with large data sets. And just like I track the like ratio on this video to see if you're enjoying it, FastMCD has its own KPIs to prove it's doing its job. Let's start with the detection rate. FastMCD achieves an impressive 95% accuracy in spotting outliers. That means nearly all the data points that don't belong are correctly flagged while minimizing false alarms. Compare that to traditional methods, which often get tricked by extreme values, and you start to see why this algorithm is such a game changer. Then there's robustness to contamination. Many statistical methods fall apart when too many outliers sneak into the dataset. FastMCD, it keeps working even when 30% of the dataset is noise. That's like trying to find a useful product review when 1/3 of them are fake and still managing to get an accurate recommendation. Next up, computational efficiency. The original MCD algorithm was powerful but slow, too slow for large-scale data applications. FastMCD changed that. It can process datasets with over 10,000 instances in under 5 seconds. That's a massive leap in speed, making it practical for real-time and high-volume applications. But what's the real-world impact of all this? It means that companies using FastMCD can trust their data. Banks can detect fraudulent transactions faster. Hospitals can monitor patient health with fewer false alerts. Engineers can prevent machine failures before they happen. In short, it's not just statistics, it's actionable insights that make a difference